Hello, everyone, and welcome back to Beyond the Business. This is a mini episode. Today, I want to talk about something that sounds like good news on paper, looks impressive on charts, gets celebrated at conferences, and same time hides a much more uncomfortable reality underneath. More solar, more wind, more gigawatts installed. But the real question is not how much we build, the real question is what actually changes. So let's get back to the main story and start with a headline everyone loves. According to Science magazine and data cited by Ember Climate, renewables have now overtaken coal in global electricity generation. Solar and wind alone grew fast enough to cover the entire increase in global electricity demand in the first half of the year. China installed more renewable capacity in a single year than many countries have built in decades. On paper, this looks like a breakthrough, and in some ways it is. But here is the first inconvenient truth. Installed capacity is not the same as used capacity. This is where the story quietly changes. Solar and wind are intermittent by design. They produce when the sun shines and the wind blows. Charts showing installed gigawatts look dramatic, but they don't tell us how much of that energy is actually absorbed by the system, used by industry, or replaces fossil fuels where emissions are highest. This brings us to the first structural issue: overcapacity. China is a perfect example. It has built renewable capacity at astonishing speed. But at the same time, it continues to build coal power plants, not because renewables failed, but because the grid, storage, and industrial demand cannot yet absorb all that clean energy reliably. Many of those coal plants sit idle, waiting as a backup. Overcapacity sounds harmless, but it isn't. When energy has nowhere to go, it gets curtailed. When it gets curtailed, the climate benefit disappears, but the material footprint remains. Which leads us to the second inconvenient truth. Renewable infrastructure is not immaterial. Solar panels, wind turbines, batteries, none of these are clean objects. They are material intensive, energy intensive, and largely not recyclable at scale today. The more we build, the more we lock in what I would call delayed waste. Wind turbine blades that cannot be recycled fully, solar panels with limited end of life solutions, batteries that depend on lithium, cobalt, nickel, rare earths. This waste doesn't show up in any celebratory charts. It shows up 20 or 30 years later. And that brings us to the third and perhaps most uncomfortable question. Where is all this clean energy actually used? Is it powering heavy industry? Steel, cement, chemicals, refining? The sectors responsible for the bulk of global emissions? Or is it mainly supplying residential demand, electric cars, and consumer level electrification, while industrial clusters continue to rely on fossil fuels? If you look at real industrial regions, the Po Valley in Italy, parts of Poland, northern France, heavy manufacturing belts in Asia, the picture becomes much less optimistic. In many cases, renewables are added alongside fossil infrastructure, not replacing it. So emissions decline slowly, if at all. This is why global emissions, according to the World Meteorological Organization, continue to rise, even as renewable capacity explodes. The system is changing, but not fast enough where it matters most. So now, zoom out even further. China today produces around 80% of global solar cells, 70% of wind turbines, and around 70% of lithium batteries, according to industry data cited by Science and International Energy Agency. This dominance didn't happen by accident. It came from scale state support, control over raw materials, and long term industrial strategy. Renewables became cheap not because they were virtuous, but because China industrialized them brutally efficiently. This creates another paradox. Globally, we are decarbonizing energy generation, but we also concentrate in industrial power, supply chains, and material extraction in one region. That has geopolitical, economic, and environmental consequences. Europe, for example, tightened environmental regulations, outsourced heavy industry, reduced local pollution, and then re-imported products along with embedded emissions plus transport emissions on top, like CBAM or ETS, carbon pricing. These are attempts to rebalance the equation economically. But environmentally, the footprint often grows, not shrinks. So, yes, renewables are cheaper. Yes, they are expanding fast. And yes, they're essential. But here's the real story: the energy transition is not just about more, it's about where, how, for whom, and what systemic cost. If we don't integrate grids, storage, industry, recycling, and geography of emissions, we risk building a cleaner looking system that still behaves like the old one. Thank you for listening. If this episode raised more questions than answers, that's intentional. Because the energy transition isn't a slogan, it's a system. And systems don't change with charts alone. See you at the next episode of Beyond the Business.